Good morning, everybody. Thank you for joining us for today's Okanagan Water Supply webinar. My name is Nelson Jattel. I'm the Water Stewardship Director for the Okanagan Basin Water Board. This is the 11th annual report out to the community, and today is intended to really provide an update on what's going on in the Okanagan for our water supply. I'd like to ask everybody if you could mute yourselves if you haven't already done so. There's going to be an opportunity to ask questions after each one of the presentations today. We have 5 presenters who I'll introduce shortly, and we'll get started here. So in terms of just a quick overview of what we're going to share together for the next hour or so, I'm going to provide for a little bit of context. We're going to talk a little bit about weather outlooks for the next few weeks. We have David Campbell, who is from the BC River Forecast Center, who is going to talk a little bit about not only our snowpacks, but what the outlook is for some of the upper elevation and sort of what's going on with some of our upper snow reservoirs. We'll then have Sean Reimer from the Ministry of Forests talk a little bit about Okanagan River and the main stem reservoirs for flow and storage. David Thompson's going to give us an update and an overview of what Okanagan groundwater is doing throughout the Okanagan. We are going to hopefully have Martin Suchi from Environment Canada provide us with a bit of an overview of what's going on in Osoyoos Lake. And we're going to wrap up our presenters with Dr. George Wang from the Fisher Outlook and what's happening a little bit with environmental flow needs throughout the region. And then I'll provide for some quick concluding remarks. As I mentioned, there's an opportunity for questions throughout. I think the best way for us to field questions is if you can type them out. But if anybody wants to just pipe up, we can also do that. As we officially start today's session, I'd like to acknowledge that we are on the unceded Okanagan territory, and it's a pleasure to be here. I'm in Kelowna today, and we have guests from throughout the Okanagan and British Columbia. So as we often do, today's 1-hour short presentation is intended to provide for an overview of key components to the Okanagan water supply. We're going to be talking a little bit about flow as it relates to snowpack and Okanagan Lake and its tributary in-stream flows. We're going to talk a little bit about groundwater, and we're going to talk a little bit about weather and precipitation and temperature forecasts for the next few weeks. This graphic here is one we show every year. It kind of contextualizes where we are in the year. These lines ultimately is the demand. This is the only time throughout this presentation where we're going to be talking about the demand side of the equation. The rest of the time we're going to be talking about really what our supply looks like. But this just shows as we get into the summer months, the demand increases significantly. And we're right now in week 20 for 2023. This is another graph that we typically show every year. Each one of these bars is an annual net inflow into the Okanagan system by volume. Just a quick few things to point out here, as we often do. The Okanagan historically has experienced multi-year droughts. And if you'll note, sort of 1929 through 1931 was a back-to-back incredibly low period. And it's something that we talk about often as we think about what our annual forecast looks like at this time of the year. The other thing to mention in this graphic is that there's a significant amount of variability when you think about 1997, where we had significant input, and then it sort of varies significantly from year to year. So this is one of the backdrops or contexts for what we manage for water in the Okanagan. It's noteworthy that 2017 in the Okanagan was a significant flood year. And you can kind of see that contextualized with what the net annual amount looked like. Of course, the other major variable here is the rate at which snow melts and how quickly we get some of these rain on snow events. So today's webinar is largely about providing for better timely information to be able to support better decisions on Okanagan waters throughout the Okanagan region. And one of the things that we contextualize today's talk is really this concept of one water, in the sense that we share this resource throughout the region. And there's significant variation between the northern parts of the Okanagan Basin, and also the sense that there's a significant difference in elevation between the valley bottom and some of the sort of higher plateau sort of hydrometric characteristics that we share here in the Okanagan. So for a quick primer on the Okanagan Basin Water Board, we've been working on water issues since the 1970s. And one of the things that we do is we look to share resources, identify problems, suggest solutions, and improve communication. We have a mandate to be able to support water governance in the Okanagan with a focus on local governments. We provide for a range of water management support tools. And today, we're also really focusing on this concept of collaborating, sharing of information, and community-to-community coordination. The Okanagan Basin Water Board takes a regional approach to practical water management issues, noting that there's significant variations between drainages. So between different subsystems or subbasins within the Okanagan. An example of a subbasin would be Mission Creek or Vernon Creek or Vaso Creek in the south. Each water source needs its own water management strategies. And because we're connected, we also need to be able to have this coordinated sense or understanding how is it that these subbasins interact with each other to be able to influence either flood or drought, the sort of two extreme ends on sort of an average year. So with that, I would like to turn the presentation over to our 5 presenters, and we're going to be starting with David Campbell, who's the head for River Forecast. David. Oh, let's go to yours, David.
Great, thanks, Nelson. Yeah, so thanks for having me here today. I'm going to talk about what we're seeing at the River Forecast Center in terms of seasonal indicators, and particularly looking at the snowpack as well as seasonal volume forecasts for the Okanagan. So on to the next slide. So I'll just run through kind of the snow progression this year. You know, really we've started the snow season off with a fairly prolonged and late fall period that remained really dry, and that kind of kicked off conditions as we came into the winter. A bit of a mixed bag as we went through the winter in terms of periods and weather events, but we saw some inklings of kind of a band across the province from northwest to kind of south central, where we were picking up a signature of higher snowpack. And the March 1st snow surveys had 124% of normal for the Okanagan. And if we go to the next slide, just looking at progression as we came into what was fairly dry month through March, we found ourselves at 113% in April, and then where we're sitting today. And interesting, we just dropped the May 1st snow bulletin probably as we're speaking here, and you can see that numbers really come up in the last month. And interestingly, a big driver in that has been the fact that it's been cool up until about up until May 1st. And one of the things we're really noting in the snow bulletin as well is those measurements really, taken May 1st or a week of either side. But we're finding that the snow melt is so rapid right now that even a week on now, the May 1st numbers are probably out of date, and the amount of melt we've seen over the last week has been dramatic. So a lot of that story of a delayed melt is now completely flipped, and we're into rapid snow melt and a real acceleration in terms of the season. So we're probably 2 or 3 weeks ahead of time. So in some ways, I think the April 1st bulletin value, 113% normal, is a good one for us to look at for what was that volume of snow relative to what we'd expect to see in the year, and having the volume coming down through the season. On to the next slide. So just drilling down, it's kind of that story, a little bit more detail. I've got a satellite image from of snow cover relative to normal for the basin. Obviously, I don't have the locations on there, but you can see Okanagan Lake and the highland terrain where we have the snowpack. And this was from April 30th. And really seeing that snow-free condition through the valley bottom, and we're really keeping that snow up in the highlands. And then just looking at the individual automated snow weather station data from Environment and Climate Change Strategy Ministry. So starting in the top left, we've got White Rocks peak, and you can see these are all good to yesterday. We can see about halfway through the snow melt there, and just working our way around the basin, we can see that the mid-elevation sites of places like Brenda Mines, Drought Lake, we're essentially in that 1,500 meter, 14 to 1,500 meter range, essentially out of snow now. And what remains is that snow up at the upper elevations, and we do see it in areas in the west part of the valley, west of Vernon, and flowing into tributaries along the northwest corner of Okanagan Lake. And we also see it in the highlands to the east of Kelowna, stretching down through into the Andricus Mountain, and the drainages divide along the drainage divide over to the Kettle Valley. And so at the higher elevations, we're just kind of starting that snow melt. But again, we've seen that rapid, and this is where we have picked up that signature of above normal snowpack. We've seen that rapid transition to pretty quickly near normal now. And I think most sites are on pace to really be snow free. And I think particularly with the weather forecast coming in over the next week, we're probably going to even transition to near record snow free date through a lot of those upper elevation sites at the way we're progressing. Next slide. So this is just a snapshot of the seasonal forecast. So we're running actually 3 different seasonal inflow forecasts at this point. We've got 2 different statistical models that we run. One from that we developed back in the early 2010s, and then a new model that was developed in 2018, I think, that we've been running. And what these really do is look at predictor variables, particularly snowpack, antecedent inflow into the lake, rainfall over the past several months at key locations like Penticton or Kelowna. And then the new model brings on additional variables such as the seasonal forecast, stretching forward for the next few months, particularly looking at temperature trends and what the forecast is for that. We're finding on the seasonal forecasts a little bit above normal for both the Okanagan Basin. So I'll look at the May to July runoff, for example, which is a good handle on what is typically the freshet flow, looking at about 104, 105% to normal for either of those models. And then Kalamalka Wood Lake showing a kind of mix between the models of a little bit above or a little bit below. So in some ways, not fully capturing that well or above normal snowpack that we saw on April 1st, but certainly trending in that side of things. We have a second approach that we use, which is simulation runoffs using a Raven model and projecting based on historic weather for an ensemble prediction. And we're seeing from that model a couple things. One, it's predicting a little bit on the lower side of things. So it's got that 94% of normal. And I think some of that is being captured by what we're seeing as the second factor, which is this early melt, which is very much showing up right now. We're seeing more typical peak inflows around about now over the last several days with the warm weather that we've had, and really seeing that shift in how the model's predicting the inflow. So while the volume might be lower, we're expecting this is really coming down quite rapidly, quite early in the season. So when we look at potential for inflow rates and how that might contribute to stream flow later in the summer, that could be one of the flags really, is with this early melt that could put pressure later in the season for creeks that rely on that snow melt component for runoff in the early part of the summer. On to the next slide. I think that's kind of wrapping my up then. Is generally speaking, we're looking at kind of that near normal runoff with shift towards early in the season and seeing that rapid melt and the potential vulnerabilities associated with that. So with that, thank you much, and I'll pass it back to you, Nelson.
Thanks so much, Dave. That was excellent. Our next guest speaker is Sean Reimer from the Ministry of Forests. Sean.
Yeah, good morning, everybody. And I'm just going to add a little bit on to what Dave was talking about. And rather than just this sort of May period, May to July period in terms of the inflows projections coming in, sort of take you through the season, very much marrying up with some of the snow things that we saw coming through the season. And where we can see that the February 1st, we had, depending on which of the models, we choose from, the old principal component analysis model or the newer one that Dave was talking about, giving different sort of projections. And we were anywhere from 100 to 145% of that inflow coming in. When I'm getting multiple sort of inflow projections coming in, we typically am discussing this with others and, try to take a little bit of a qualitative assessment of what's going on in the mountains and things like that. So when we were seeing an above average snowpack developing, we tend to choose the higher number, which for planning purposes we did starting back in February, and we started to lower the lake. And just the fact that we were seeing a little bit lower inflows than normal through that period, again, that even makes the lake difficult to actually sort of keep from dropping. So going through the season, you can see that again, we had a little bit normalish to quite a bit higher than normal starting in February, and our forecasts then got to where we are now, around the 104, 105% of normal range, depending what using. So from my perspective going forward and seeing that we still have an above average snowpack, although like Dave said, we're probably getting closer to that normal number because of the early snowmelt, but we're using this 420 million cubic meters of water expected to come in between now and the end of July for our planning purposes. And so again, that number, we're trying to make that number to give us a certain flexibility in our operations. Next slide. So this is some output from our fish water management tool, which uses the forecast number, the volume forecast number, as well as a schedule of releases from Okanagan Lake. And then that will then project where we're going to be getting to in our lake level. And none of these things, including Dave's forecast, will really can consider sort of extreme weather conditions that could arise. But again, we're trying to look at some flexibility. So what you see here, the black is where we've been to this year. If you go back to February, you can see that the outflows were increased because of that earlier large forecast. And then as the season went by, we decreased them a little bit. So we are projecting that we might go up to about 40 cubic meters per second coming out of Okanagan Lake. Again, that's very moderate. So we certainly have room to either increase or decrease as weather conditions arise. But right, the next slide, what we'll see is where that takes us to. And the blue, of course, is our forecast. So, oh, no, it's okay. Next one is fine. So again, the black is where we've been to so far this year. And the blue line on this graphic shows us the projection based on those other factors and inputs. So our right now, we're looking to get to about 20 centimeters below our full pool target, which is sort of the highest little green diamond you see. You can see some of the potential impacts that our operations so far led to on some of these other interests that we try to plan for. The kokanee survival, because we took the lake down this year, the drawdown can potentially impact some of the shore spawning kokanee. Some of the monitoring has suggested that it was somewhat of a muted impact this year, which is positive. I think we're going to have to wait and see a little bit for the final sort of monitoring results there. But things were looking a little bit more optimistic maybe than my harsh red line there suggests. And again, outflows are going to be decreased, increased as conditions warrant going forward. So next slide. So what we can see here, of course, is a good representation of, again, what Dave was talking about as well, where we've gone from sort of a cool period, and then we went straight into that warm period, where you know, the inflows into Okanagan Lake are really a consequential result of that. So that the inflows right up till sort of this last week were basically below normal through the late winter and early spring period. And then you can see almost double the normal inflow through that last period, through both snowmelt and through the sort of Friday and Saturday rainfall that we saw coming in. These black lines are the average or normal inflows, and that they represent the week endings on a Saturday. So you know, again, the Friday and Saturday, some of the Saturday rainfall and precipitation will have been captured. And so the little green line that you can see on this week is just a sort of a partial week. And I would expect that by Saturday, I doubt we'll see the same inflow that we saw last week, but it will very likely be still higher than average going forward. So again, representative of that enhanced melt that we are just seeing over this period right now. And I believe that is all I have, unless there's some questions later.
Great. Thanks so much, Sean. That was great. Our next guest speaker this morning is David Thompson, who's the regional hydrologist here in the Okanagan. And one of the things that often is missed is groundwater because it's unseen. And so it's great to have David with this presentation. David, take it away.
Thanks, Nelson. Thanks for inviting me to present the current groundwater level conditions in the Okanagan. I'm a regional hydrogeologist and a member of the South Area Groundwater Science team. Our staff is in the Ministry of Forests, and despite the name, we do have a mandate and operational focus, including groundwater monitoring. And we maintain a network of groundwater observation wells throughout the Okanagan and the rest of the province to monitor groundwater levels. So if you go to the first chart, I'll just orient people to what you're going to see for the rest of them. On the right-hand side, there's going to be this map showing where we are in the Okanagan, and that will fade. And then at the top of the chart, we've got the observation well number and location. Measurements are presented as the depth below ground surface. So when the lines go down, water levels are going down. You can just advance just to remove that, Nelson. Thank you. Yep. The charts for the water year, which starts in October and goes through to the end of September. The black and red line is the current water year, with the red line being data that hasn't yet been checked. The gray line is the calculated historical daily median. And then the historical daily minimum and maximum ranges are color-coded with percentiles to better understand the current conditions. You can see much above normal is that purple one, and that represents above the 90th percentile, much above normal. Light blue is above normal, between the 75th and 90th percentile. Green is normal, between the 25th and 75th percentile. Yellow is below normal or less than 25%. And then that brownish color is much below normal, less than 10%. So this chart and all the subsequent ones are showing data as current as of last week on Tuesday, I believe. So this well is observation well 180 in the township of Spalmachine, just north of where I'm talking to you from, Vernon. Last year, the dotted line had upper normal to above normal levels at this time of the year, and groundwater levels currently are similar to last year, at upper normal to above normal time. Next. Moving down south, just north of Kelowna to observation well 442, located southeast of the Kelowna Airport on Black Road. If you could just remove the map, Nelson. Thanks. Last year, the 2022 water levels were trending toward the upper range of normal, and this year levels have been tracking similar to last, but still in the upper end of normal. Next. Now we're in Kelowna, observation well 236. You can probably just spend a couple seconds on that map slide, Nelson, and just, yeah, thank you. This is in Kelowna on the north side of Mission Creek. Levels are currently tracking along the upper normal levels similar to last year. Next slide. Upper Trout Creek off to the other side of the lake in the mountains. This is a bedrock aquifer higher up in the watershed northwest above Summerland. And here you can see normal levels throughout the winter, but delayed response to spring recharge. And currently, or at least as of last week, levels are near historic highs for this time of the year. Moving south, Twin Lakes, observation well 403. Levels are tracking below the median and similar to last year, but still within the historical normal range for this time of year. Observation well 282, Whittlebrook. This is installed in a confined sand and gravel aquifer and is looking similar to Twin Lakes, where levels are tracking below the median values, but still within normal range. Next to observation well 407, north of Oliver. Water levels began the year tracking similar to last year and presently are in the below normal range for this time of year. This may reflect precipitation patterns so far this year. Groundwater levels have been below, oh sorry, we're in Oliver now. The groundwater levels have been below historical minimums for the water year so far. Based on the historical pattern evident, water levels generally begin to respond to recharge over the coming months. And finally, our last slide, observation well 402 at Anachrist Mountain. This is another bedrock well higher up in the watershed above the main valley. And the pattern here is similar to the other bedrock well shown at Trout Creek. Currently levels are trending toward the high end of normal range as that recharge sets in. Next slide. So in summary, in the North Okanagan, we're within the normal to above normal range. In the Central Okanagan, more toward the upper end of the normal range. And in the South Okanagan, generally low, below the lower range of normal to historical lows. Groundwater levels can vary between localities, as you've seen on this presentation. So best to consult local real-time stations for current conditions. And the next slide will show you a link to that. This is a link to the provincial groundwater interactive map. It does get updated once in a while, so sometimes the link breaks and moves around, but you can just go to the internet and type in something like BC Provincial Observation Well Network, and you'll find, in all likelihood, this interactive map, and you can collect what data you want from it and graph it or view updates to it. Regional contacts are based in Vernon, Penticton, or Kamloops, and there's a list of our names and telephone numbers and email addresses on this chart. So with that, thank you, Nelson, for the opportunity, and thanks everyone for your time.
Thanks so much, David. That was a great presentation on Okanagan groundwater. Next, we move to our next speaker, who is Dr. George Wang, who's going to be talking a little bit about environmental flow needs in the Okanagan. George.
Yeah, for sure. Good morning, everyone. My name is George Wang, the hydrologist with the ONA Fishery Department. The EFM project is a great partnership between ONA, OBWB, Flint North. It also demonstrates the First Nation partner is leading the science side of a complex, highly technical project. The photo you are seeing was taken in August 2022. It shows the dry stream bed of about 1.2 kilometers in McDougall Creek. Next slide, please. This slide shows the history of the development of EFN policy. As you can see, the new policy became effective on March 2014. Thereafter, it has been amended 3 times. The most recent amendment was made on February 2022. It was updated to distinguish between EFN risk assessment, formal EFN determination, etc. Next slide, please. There are 2 important definitions in Water Sustainability Act. The first is environmental flow needs, which is in relation to a stream, means the volume and timing of water flow required for the proper functioning of the aquatic ecosystem of the stream. The second is critical environmental flow threshold, which is the volume of water flow below which significant or irreversible harm to the aquatic ecosystem of the stream is likely to occur. Next slide, please. This slide shows the 18 streams we targeted for the recommended EFN and critical flow. The study tributaries were selected and prioritized based on criteria including fish habitat value, current water use pressure, and future water demands. Next slide, 1. The Okanagan EFNs were established through a comprehensive effort that included stakeholder collaboration, literature review, which resulted in 2 primary methods in phase 1, the Okanagan tenant method and the Okanagan weighted usable waste method. In phase 2, EFNs were recommended for all 18 selected streams using the Okanagan tenant method and refined for 10 streams using the Okanagan weighted usable waste method. Critical flow were also recommended for all streams. Next slide, please. This is our current hydrometric network. As you can see, it includes 19 hydrometric stations. 14 out of 19 are real-time stations, and we are planning to feed these data into provincial hydrometric database. This network covers most of the important tributaries within Okanagan Water Basin. And this data can be used for the land use and transportation planning, flood forecasting, drought management planning, protecting in-stream flows for the fish, which is also known as the EFN determination, and others. And next slide, please. This is the flow chart of Okanagan tenant method. As you can tell, the complex of the process of this flow chart. Next slide, please. So that's the flow chart of weighted usable waste method. I will not give you the details due to the limitation of the time. If you are interested in this part, you can always reach out to me. And next slide, please. And this is an example that's showing how we set up the weighted usable waste at Equisys Creek. Those are photos of the setups in rifles. Next slide, please. And those are set up at the glides. The next one, please. This is our ongoing real-time station at Equisys Creek. Next one, please. This table listed the EFN summaries for Equisys Creek based on species and fish periodicity. And next one, please. This figure displays the weekly EFN, critical flow, and stream flow in Equisys Creek throughout the year. Next one, please. As you may see, the estimated maximum licensed flow indicates that the stream would be dry from late July to mid-September if licensed withdrawal and storage volumes were maximized. And next one, please. The Okanagan EFN project aimed to produce transparent and robust EFN for Okanagan streams. The next step involves reviewing EFN and critical flow recommendations for each stream with input from community members. Once a technical report is agreed upon, A collaborative effort will balance water demands with ecological needs within a societal economic context. The final step is to develop an implementation plan with the goal of using EFN for Okanagan water law development. The ONA, a Natural Resource Council, and the Chiefs Executive Committee will be involved in implementation planning. Next slide, please. Yeah, at last, I would like to share with you one of our faiths. So water is a part of us and a part of our life, and water must be treated with reverence and respect. This is an excerpt from Seal Water Declaration, and yeah, I hope this could be some of the take-home message. And I will pass this to Nelson. Thank you.
Thank you much, George. That was a great presentation on environmental flow needs. I'm now going to ask Dave Hutchinson to share his screen, and we're going to get our next report about Osoyoos Lake and some of the stuff from the IJC.
Can Nelson
Yes.
just jump on here? Are you able to unmute Martin? And,
Yes, I believe Martin is unmuted.
Can you guys
check
hear me?
on that.
We can.
Oh yeah, we
Yeah,
can.
loud and clear.
Now, would you? I can present my screen. Yeah, Martin. Let me just set this up here. Unless you don't have the presentation, do you, Nelson?
I could also get.
I did send it to both of you. But
Perfect.
I apologize. Technical issues connecting this morning.
No problem at all. Let's see. Yeah.
If you want, I can share my screen, Nelson.
Okay. Yep. Go for it.
How do I do that? If this works here, let me try
If
this.
not, I've got it too.
I don't think I'm having technical difficulties too. I don't think I
No
can
problem.
select.
I'll share my screen and
Okay.
we can do this here. Let's see. Share.
Just let me know when you're on the title page there.
Okay, Martin, we're good to go.
Okay. Thanks, Nelson. So I'm going to do a quick presentation here for the International Osoyoos Lake Board of Control. So I'm the Canadian Section Secretary for that board. You're seeing here an image from a USGS webcam at the USGS Hydrometric Station, Okanagan River at Oroville, and that is Zozel Dam, who is the applicant for the Board of Control and the rule curve that they're following for the operation. So the other thing I also wanted to mention is the information that we're providing and relying upon comes from various sources, like the BC River Forecast Center, the Northwest River Forecast Center, the Okanagan Lake Regulation System, so stuff from Sean Reimer, along with USGS stream flow gauges, and same with Water Survey of Canada gauges. Next slide, please.
Yep.
Next slide here. So just a quick overview of the watersheds. So Osoyoos Lake is the transboundary lake right at the border, which is in the Okanagan Basin. But we also look at the Similkameen Basin, which is in yellow there, because the confluence is below the lake, but it can affect the outflows from Osoyoos Lake. So again, in quick summary, the IJC appointed the Osoyoos Lake Board of Control to monitor the provisions of the orders. There's numerous revisions of the orders over the years. And the current order, which is from 2013, there's two primary rule curves, a normal conditions rule curve and then a drought conditions rule curve. So we look at possibly declaring a drought if the conditions are applicable. And again, it's generally Zozel Dam regulates Osoyoos Lake, but at times the Similkameen can also have an influence. Next slide, please. So just a quick overview. This is 2022. So since we did the last water supply webinar in April or May of last year, the green line represents Osoyoos Lake, and the black line represents the normal conditions rule curve, so we call that condition 7. The red dashed lines represent the condition 8, which is the drought rule curve, which allowed the lake operator, which is the Washington Department of Ecology, to operate with a larger range, both maximum and minimum during the summer period for the lake level. For 2022, it looks like the lake level exceeded the rule curve. That's true, although they were still in compliance because the gates were fully open in the lake at Zozel Dam. And the rest of the year followed kind of predictable target elevations. Next slide, please. So in terms of 2023, the drought criteria and forecast. So there's three conditions within condition 8, 2 of which have to be met. The Similkameen flow volume has to be met, and then 1 of 2 of the Okanagan Lake, either lake inflow, net inflow, or lake level have to be met in order for the board to be able to declare a drought and the operator being able to operate the dam under these drought conditions and drought rule curve. So for 2023, the Similkameen, that threshold is 1 million acre-feet of flow volume for the period of April 1st to July 31st. Early forecasts for 2023 on April 1st and May 1st look like those that criteria would be met for a drought declaration. Although saying that in the last week, that forecast has changed to just above 1 million acre-feet. You see that in the red in the last column there. So as of right now, that would not be met. In terms of the other 2 criteria for drought declaration, the net inflow is 195,000 acre-feet or less than 195,000 acre-feet for the period of April 1st to July 31st, which is the equivalent of 241 kilodams there. Again, we're well in excess, so that criteria both in April and in May here, so that criteria is not being met. And similarly for lake level, again, these are some forecasts from Sean Reimer. The criteria is 1,122.6 feet. Again, I'm using imperial here because the orders are written using those units. And again, the forecasted values both from April and May are above that value, so the criteria is not met. Next slide, please. So just a little bit background on some of those that information that I presented. So again, just acknowledging that this is information data that's coming from others. So the BC River Forecast Center in terms of the modeled Okanagan net inflow. So that's the table on the left there. We've got the fish management tool and projected lake levels for Okanagan Lake from Sean Reimer. And then the plots on the right here, the top plot, that's basically just showing the cumulative net inflow for April to July. The orange line is where we are now. And as long as we surpass that dash red line by the end of July, then the criteria is not met. And you would need to be down near the 10th percentile of the net inflow in order to not meet that criteria. And then the bottom 2 there just have to do with the Okanagan Lake levels. But again, Sean has shown that already. Next slide, please. For the Similkameen forecast, we rely on a water supply forecast from the Northwest River Forecast Center, again, for the period April 1st to July 31st. The plot, that's the table on the right, and that's looking at the 50th percentile there. For the forecast, this is in acre-feet or 1,000 acre-feet. So again, right now, as of yesterday, we're above that threshold. The plot on the bottom left just shows what that forecast was on a daily basis throughout the water year here. Again, we are just over that threshold. The plot on the top right-hand corner shows the volume of the Similkameen River with the orange line there, and we have with the recent warming and snowmelt that is climbing and is projected to be in excess of 1 million acre-feet. Let's just move on to the next slide, please. So Similkameen River at Nighthawk. So this is USGS station. Again, a large increase in the flow in the past week due to the snow melt. The top right is the snow pillow station at Blackwall Peak. Again, so we've peaked in terms of the SWE at that station, and it's beginning to decline, and it's earlier than average for the period of record. And then here's a 10-day projection for the Similkameen River at Nighthawk discharge, which appears to be stabilizing, although variable. Next slide, please. Over into the Okanagan system, again, these are hydrometric stations for the Okanagan River at Penticton in the top left-hand corner, and showing operations since January 1st. And then in the bottom is bottom left is Okanagan River near Oliver, and that represents the inflows through Osoyoos Lake. And you can see this large spike that's occurred in the past week with snowmelt beginning a freshet, and flows increasing substantially and representing tributary inflows into the Okanagan River main stem. Here, just on the right, a couple of the snow pillow stations that we monitor for the Okanagan system, so Mission Creek. Again, we've peaked there in terms of SWE and have been declining in the past week, and Grayback Reservoir as well, substantially decreasing in terms of the snowpack and the snow water equivalent there. Next slide. Okay, so at the end of the day, Osoyoos Lake level. Current 2023 is the dark blue line here. As you can see, again, lake levels rose rapidly in the past week due to the increase in inflow from the Okanagan River. The other lines are just previous the past 5 years. So again, 2023 is following the same trend as 2022 and 2021, and following the target rising limb. And we have just, as of yesterday, surpassed the rule curve at 912 feet. But again, the all three gates are open, and the operator is in compliance. In the top right-hand corner of the plot there, we're showing the Okanagan River, sorry, at Oroville. So this is USGS gauge just downstream of the dam. Again, a rapid increase in flows. And so that's telling us that we're not getting any backwater effect from the Similkameen flows right now, because those flows, the outflows have allowed to increase for the Okanagan River at Oroville. That's it. Thank you very much.
Thank you very much, Martin. That was an excellent summary, and really appreciate bringing in some of the snow pillow data. That is it for our presenters. I'd like to thank all of them. We have one question that's been written in by Joe Fries, and I'm just going to ask it, and then there's been a couple of answers already, so that's great. So Joe asks, if you had to write a headline to sum up your presentations, what would they be for both Dave and Sean? Dave noted near normal inflows in an early and rapid snowmelt season expected for the Okanagan Basin. And Sean writes heavy early inflows into Okanagan River, but moderate Okanagan Lake inflows. So thank you very much for the question and those two answers. I'd invite anybody else. We've got about 5 or 6 minutes here. If anybody has questions that they would like to ask of anybody on our panel, and you can either raise your hand or unmute yourself or type into the text box.
Hey, Nelson, it's Sean here. I might just make a comment,
Sure,
you know,
please.
from Martin's thing. It's just, you know, one of the reasons we're seeing Osoyoos Lake so high over this last bit, or rising above the rule curve, or the rule there is, you know, we had extremely high flows from Inconneet Creek going directly into Okanagan, or sorry, Osoyoos Lake. we were seeing above 20 cubic meters per second directly from the Water Survey of Canada gauge. This provisional data, and I know that I think that gauge is somewhat subject to some problems at real high flows, like a lot of these smaller creeks. But certainly haven't seen anything like that since 2018. And as well, even though I have a very moderate flow out of Okanagan Lake, all of the tributary inflows, because a lot of the rain that we saw on the weekend, on top of a pretty heavy South Okanagan snowpack, really got those tributaries into Okanagan River going, like Shuttleworth Creek, Vassaw Creek, Testalinden Creek. And so that the difference between flows when they peaked was 70 cubic meters per second between Okanagan Lake and what was going into Osoyoos Lake. And again, that's not counting Inconneep Creek. So we haven't seen a difference in sort of the flows since 2018 like that.
Great, thanks for that, Sean. Okay, we have about 4 minutes left. So once again, if anybody would like to ask a question, you can just raise your hand or unmute yourself and let us know what yours is on your mind. All right, well, seeing that I think we've answered all the questions, if there were any. I wanted to thank again my team of panel experts this morning, David Campbell, Sean Reimer, David Thompson, George Wang, and Martin Suchi. Really appreciate everybody's sort of opportunity to come and talk to this group. This has been recorded, and we will make sure that it gets posted in a number of places, including our website. And with that, I hope everybody has a wonderful Tuesday, and looking forward to seeing you next year at around this time. Thanks, everybody.
Thanks, Nelson.
Thank you, Nelson.
Thank you, Nelson.